this section, we're going to look at Hamilton circuits and paths. So Hamilton basically flipped the idea of the Euler circuit and path around to look at the vertices instead of the edges. So in this time, we're wanting to see, is there a possible path or circuit in which we can touch every vertex once and come back to the vertex we started at, not worried about like the touching every edge. So for example, in this one, we could start at A, we could go to B, we could go to C, we could go to D, we could go to E, and we could go to F, and then if we not go back, but kind of go back to A, we've touched every vertex once when we do that. So A, B, C, D, E, F. That was almost two. So we hit every vertex once, but we're not worried about the fact that we left a couple edges off. All that we're worried about is that we went to each vertex exactly one time. All right, let's look at the next one. On the next one, if we started to say at E, we go to D, and then we go to A, and we go to B to C, but we can't really get F because we've already been to D. We're trying to only visit each vertex once. So no matter how we really start, because the way E and F are laid out, I don't think this one's going to be possible. So if we start at F, and then go to D, and then go to A, go to B, and then go to C, we can't make it to E. So on this one, there's not really one possible to touch every vertex. So not possible to touch every vertex, or create what's called a Hamilton path or a Hamilton circuit. Alright, on this one I think we can do it. If we just start at A, we go to B, we go to C, we go to D, and then we go to E. Now we haven't created a circuit, but we created a path. So in this one went A, B, C, D, E. So in this case it asked us, we basically made a Hamilton circuit with the first one, because we touched every vertex once and came back to where we started, and we created what's called a Hamilton path with the last one. Alright, let's try it with a little bit more complex looking graphs. Alright, again, it wants us to create a Hamiltonian circuit or path, and you always try to make the circuit if you can, and if you can't, then you go for a path. Alright, so let's see where we might want to start with this one. If we started at, let's try just a couple different examples. We could start at C, and then we could go to B, and then we go to A, and then to F, and then we're kind of landlocked, so that was no good. So let's try again. Maybe let's try E, D, A, B, C, and then F. So at the very least we can create a Hamiltonian path on this one. So let's write that down just in case we forget it, because sometimes you can make a Hamilton path and a circuit. Unlike the Euler circuits and paths, there's no technique or algorithm to really show whether or not completely a Hamiltonian path exists. There is one that shows if a Hamiltonian circuit exists, but it's not a bidirectional statement, so it doesn't work as well as the Euler circuit definition. So let's write this down so we have it. E, D, A, B, C, F. See if we can find any other ones where we can actually touch and come back to where we started. So let's try F, go to A, go to D, go to E. Again, another example of a Hamiltonian path. There's lots of different ones. Again, B and F, we touch every vertex, but we can't get back to F without going through a vertex we've already been to. So we could try another one. Maybe start at D this time. And go to F. So again, another path, because the B and D are not adjacent. Alright, so at the very least we have a Hamiltonian path. Let's see on the last one if we can come up with a Hamiltonian circuit for this one. So if I go to A, and then to D, and then to B, and then to E, and then to C, sure enough, the last one I can make it to, so that would be a Hamiltonian circuit. So we started at A, then we went to D, then we went to B, and then E, and then we went to C, and then back to A again for Hamiltonian circuit. A, D, B, E, C, A. Alright, for most of these, what I'll probably do is tell you that if a Hamiltonian circuit or path exists, and then you just have to locate one. So again, I'll start on this one, maybe like start it here and go to A, D, H, G, F, E, B, and it looks like I lucked out this time, C to I. So if you look carefully, we've hit every vertex exactly one time and made it back to where we could now make it back to A if we wanted to. So let's list that. So we started at A, then we went to D, then H, then G, then F, then E, then B, and then finally C, I, and then back to A. Alright, on this last one, again, same concept. They tell us that only a Hamiltonian path exists. Again, at any point, you can pause the video and see if you can find it yourself, and then restart the video to give you an idea before you take these quizzes. But let's see if we can find a way that we can touch every vertex once. So maybe A to B to D to F to G to H to I to J to C to E. That wasn't too bad. We've hit every vertex once, and our starting and ending places aren't adjacent, so it's only a path. So now we just need to list it. A, B, and then we went to D, F, G, H, I, J, C, and E. And there's tons of correct answers. There's a lot of different ways you can do that, but as long as you can list one, we're in good shape. I hope this gives you enough of an idea what a Hamiltonian circuit and path are. Good luck on the quiz. Please ask your teacher if you have any questions.